All right, so the last factor we'll look at for aquatic systems is something that's called seasonal variations in northern lakes, or the fall or spring turnover. Spall comes from spring and fall. Anyway, so now over the course of the year, the temperature of lakes tends to change, right? So in the summer, for example, we're going to have um, warmer temperatures near the surface, and then this area of of very fast cooling, and then cool waters in the depths. Okay, so epilimnion is the upper layer, which is the warmer layer. The thermocline is where we see the change in the temperature, and then the hypolimnion. Some of you may have experienced this if you go swimming in the ocean, maybe, or in a lake in the summer, and it's nice and warm. It's like August, all right? And then you dive, and you're gonna hit this area that is just gets super cold right away, and then you can dive further into the colder waters. So maybe you've had this experience, maybe you have not. So because the warmer waters are warmer, they're less dense than the more dense cool water. So we have this density gradient here. So the upper waters will sit very nicely on the top, and we'll have this stability here in the summer. Okay. Now, when we move into, there it is, okay, into the fall, and the temperature starts to fall, okay, the epilimnion will begin to cool off and get colder than the hypolimnion. And so this density gradient will start to change, where the epilimnion water will be heavier than the hypolimnion water, and so it'll start to sink. All right, and these currents will start to flow, and then this is very, very, very good for aquatic systems. Before I talk about the goodness of that, just to note that the most dense water is at actually 4 degrees. So this is the density of fresh water curve. You can look that up, all right, on the internet if you like. Okay, and this is just the density of water curve here, and we notice at 4 degrees it's at the highest density. So it just doesn't take the water to get super, super cold, just to 4 degrees, and then it starts to sink. Now, if we consider that this water has been sitting there, my goodness, in the epilimnion over the summer, and it's been churned with air and wind, and it's been oxygenated, okay, those oh my goodness. Anyway, those waters that are sinking are carrying oxygen with them to the depths. All right, so we're having this oxygen enrichment of the depths of the lake. Whereas the water was being pushed up, okay, the less dense water, which is being pushed up, that has been sitting in the hypolimnion, is going to be more rich in nutrients. All right, and so we have this exchange of oxygen down, nutrients up in the fall. Okay, so yeah, so that's about it, really. And in the spring, the whole thing happens again. Okay, where there'll be ice cover, of course, in the winter. Okay, as the ice melts and the water reaches 4 degrees, it will do another spring turnover, we call it, just like the fall turnover, where the upper oxygenated layers will sink toward the bottom, and the lower nutrient richer layers, because they've been hanging out with the benthic layer, right? If you remember that, you should, from from our lake discussions. Oh my goodness, there we go. From the benthic layer here, we'll be moving nutrients up to the surface. And so we have this continual regeneration of oxygen and nutrients that are cycling through lakes in northern lakes, right? Because of seasonal variations of lakes. Cool? Cool. That's about it. Okay. Stay safe, stay healthy. See you in the next lesson.